The sample that I had here, this is inspected at the refinery. In addition to that, samples are taken at our asphalt plant, and those are retested. Go ahead.
This is the glue that you use to
Absolutely,
mix,
yeah. That
and it's hard now. Now, what temperature would make it fluid?
you probably are going to be required to keep that at about 350 to 400 degrees.
Fahrenheit.
Yes, Fahrenheit.
Okay.
In order to get it to flow through your pipes and your spray bars and those types of things.
You make the mix, and how long would it take from the plant to drop it where it should be?
You have, I'll get into that too, but you have about an hour.
An hour.
Yeah, not too much different than a cubic yard of concrete. Any of you guys and gals ever finish concrete? Okay, you know when that comes out. I don't suppose any of you laid asphalt. Okay, well you've got an idea. When it comes out there on a truck, you've got a certain amount of time for the concrete to get it out of the truck into the forms, to get it consolidated, whether you're using a shovels or a vibrator, and then get it smoothed off. Same thing in asphalt. You have a certain amount of time, and as far as the state of Illinois is concerned, they say that time on concrete is about an hour. As far as asphalt, they look at it from a temperature standpoint. And if your mix temperature goes much below 275, then you're not going to be able to compact it. And if you can't compact it and get the proper density, then they'll reject it.
If
Go ahead.
concrete hardens, you throw it away. If asphalt sets or hardens, can you?
Well, no, you can't. But we don't throw the concrete away. We bring it back into our plant sites, and then we crush it, and then you use it as shoulder stone, or you use it as aggregate base. Because of disposal problems, very little concrete or asphalt is just being thrown away anymore. We probably crush anywhere between 40 and 60,000 tons of asphalt or concrete a year, and that's just our company. Reinforcing steel, we're getting ready. This is again on Interstate 70. We've raised this bridge deck substantially, but you see the reinforcing steel in the parapet wall, and that's coated with epoxy. That has been inspected at the point of manufacturer, and then when it comes out on the job, we're required to cut off several pieces and provide it to the state so that they can re-inspect it. Go ahead. This is liquid asphalt storage tanks. These are vertical tanks, and the material comes into our plant 350 to 450 degrees. We pump it in the tanks. They're heated, they're insulated, and then it's ready to be used. If you let it cool off, like we'll have some in there over the winter, and we'll have to heat it up for next spring, it probably takes about, I think my people tell me, about 4 gallons of fuel oil for about every 10 degrees that you want to raise that liquid asphalt. So it becomes an extremely expensive proposition.
The inside of these tanks are pipes or just empty containers?
Inside of those tanks are pipes. And we pipe, and it starts down here. This is what's called a hot oil heater. And this framework starts here. And these are just full of pipes. And we actually pump hot oil through the pipes, and it's a heat transfer mechanism that then heats the oil. We'll just hold that for a second. Talking about construction and horizontal construction for a while. No, let's go back to that other slide. The majority of construction companies in the state of Illinois and in the United States are still family owned. As a matter of fact, even though we're seeing consolidation around the country, and in some states a lot more than Illinois, but nationally I still think about 90% of vertical construction companies are family owned, and something like 81% have 4 or 5 owners, and that's all. In our company, we're 54 years old. My daughter is our 3rd generation. After she graduated from college with a degree in economics and then got her MBA, she went to work for another firm for about 3 years, and now she's been working for us for about 8 years. Our business is primarily paving, both asphalt and concrete, but we also do bridges, and we do curb and gutter, we do stone, we build box culverts. Particularly in rural areas, you pretty much have to do it all if you intend to be successful. Paving, at least in the asphalt business, is controlled by your plant locations. Just like if in the ready-mix business, you'd be controlled by your plant locations. As I indicated, asphalt will remain hot where it's usable for about an hour. You mix it, drop it into a truck, haul it somewhere for 30 minutes, get it into your asphalt paver, get it spread, get it compacted. That's about an hour. That's kind of what the state looks like. We have 10 locations, and the plant at Casey is not here any longer, but Greenup, Charleston, Mattoon, Shelbyville, Vandalia, Centralia, down here at Barn Hill, which is at the intersection of Route 45 and I-74, Mount Carmel, and Flora, Illinois. So if you'd kind of take a protractor and draw 30-mile radius around those things, you would kind of get an idea of where we actually operate. Everything we do is primarily hard dollar contracts, very, very little negotiation in our contracts. Bidding is straightforward, whether you're working on a horizontal structure or a vertical structure. You start with your labor costs, you've got your material costs, you've got your equipment costs, and then how much time is it going to take to do it. Everything we bid, and I think most contractors are the same, it's all on computers now, and the yellow pad type of bidding or estimating that I used to do, you don't do that any longer. But you still pretty much stick build things or stick estimate things. In other words, we start with those basic components and you build them up, because every job is a little bit different. When you get done figuring your costs, then we of course go back and look at our history on a box culvert or on a paving project or on a bridge project. But you make a real mistake if you just try to look at averages and try to do everything on averages. That's a lot of contractors get in trouble doing those types of things.
A question, please.
Sure.
You mentioned something about yellow pads.
Yes.
System and computer and software. In this generation where everything is just punch here and choice yes, no thing, how would you balance between knowing really what the computer is doing and being just a pusher, yes, no, yes, no, yes, no? That is an interesting question, and something that is extremely important, because you will need to have an idea on what the answer needs to be before the computer spits it out. And what I mean by that is that if you are working on a building project and you're doing the forming, you need to have a general idea in your mind what that cost is going to be, or you may get something out of the computer that that doesn't relate at all. It may be way too high or it may be way too low. And if you don't have that basic gut feeling about what that price ought to be, then you can really make some serious mistakes. As an example, everything we do is hard dollar, and once we submit that bid and once we sign the contract, then we're obligated to build it for that price. As I indicated, it's not a negotiated thing in public works construction. You might be able to go to a private, if you're doing a driveway or building a house, and say, hey, I misfigured the form lumber, or I misfigured the roofing material. The owner might have some leeway. In a state contract where it's been bid competitively against other people and the bids are read in public, you don't have that option. Whatever you've bid it for, that's what it'll take. And probably one of the biggest dangers is if you're bidding something, and let's just say you're bidding a concrete floor in a box culvert or in a building, and you're bidding that on a square yard basis, but you're going to buy the concrete from the guy on a cubic yard basis. The concrete supplier, he doesn't care whether you've made a mistake or not. If you have bid it that it's going to take 350 yards of concrete and it takes 380 yards of concrete, you're going to get charged for 380 yards of concrete. He doesn't care. And so if you don't have in your mind, the fact that that big a structure is going to take more than 350 cubic yards of concrete, you can be left holding the bag for an additional 30 yards, or if you've made a really big mistake, an additional 100 yards of concrete. And and that square yard price may be as much as $100 a square yard. So you've got to have a gut feeling, as to what it's going to cost. And probably the only way you're going to get that is to be out on the job for a period of time, either working out on the job or as an assistant project supervisor. But the estimators in construction are pretty talented people, and as a construction company owner, you've got to have some of your best people doing the estimating, because if you get the job at the wrong price, you've lost money before you ever get started, and you have to, as I said, complete the project. Go ahead. After we bid a project for IDOT or most municipalities, after the award, then you normally have 15 or 20 days to get your subcontractors lined up, to get your bonding in place, to get your insurance in place, and those types of things. And then you have to start the project. So again, it may not be something like if you're building a part of a subdivision or building a home for somebody, you tell them, well, when I finish this home, I'm going to start on your home. The state doesn't, they don't buy that type of thing. What they say is, you've bid it, here's the date, 20 days later you're going to start the project. So as a highway contractor, you have to have a lot of flexibility in both your workforce and in the equipment that you have. I want to talk about prices for just a little bit, and of course the hot topic today is the price of a barrel of oil and the price of a gallon of gasoline. I also want to look, though, at reinforcing steel and at cement, because again, those products affect your vertical construction just as much as they affect our horizontal construction. Petroleum asphalt, which is what is in this jar, is a derivative of a barrel of oil, and I want to refer to these things for just a second, the handouts. And originally, petroleum asphalt, this product, used to be a residue of oil production. So if you look at the little chart that I have here, and on the left-hand side you see sand and water, then you see petroleum down here at the bottom of the well, and then you see gas, and that gas is not gasoline, that gas is natural gas. So if you've driven through an oil field south of Mattoon, you oftentimes see flames coming up from the oil wells. Well, that's the natural gas that's being burned off. So then it goes into the refining process, and I'm not going to spend too much time on this page, but it shows light distillates, medium distillate, heavy distillate, and then down here it has residuum, and it shows asphalt cement. Well, that's pretty much the way things used to be. Now I want to go to the second page and show you kind of how things are today. After they get the crude oil, it goes into the crude tower over here, and they start, what we say, they start pulling things out of the oil. The first thing they pull out is gasoline, and I think it's no secret that the petroleum companies make more money on gasoline. And one of the things is you can look at the temperatures over here, 60 to 325 degrees Fahrenheit during the production process. So it's easier to get gasoline off. So the first thing they pull off is gasoline. The next thing they pull off is naphtha. Naphtha is used in a lot of chemicals that we, cleaning fluids and chemicals that we use. That's the next thing that comes off. Then kerosene, which produces jet fuel and heating oils. Your lighter oils such as maybe number 2 diesels and things like that would be here. Then your light gas oil, and then you see a thing over here called cracking. And I'll talk about that in a second. Then you get down to heavy gas and oil, and the heavy oils would be the number 6 fuel oils that are used in factories, particularly up north, for heating those major factories. They don't use number 2 diesel. They use heavy oils, number 4s and number 6s. Then you see this thing over here called a vacuum tower, and that's something that's not relatively new, but something that is a very expensive addition to a refinery, and so you don't see a lot of that. But when they send something through a vacuum tower, they're actually able to extract more gas and more oil off of it. But then also you see down here where it says it goes to pitch, resins, asphalt blend stock, or coker feed. That's extremely important because what has occurred, and I think that it probably began in World War II when all of a sudden we needed to have a lot more silks and nylons and rayons. And if you recall, a lot of the silks came from Asia, and the Japanese had conquered a lot of Asia. So we needed things to make parachutes, we needed things to make uniforms and packs and all of that type of thing. So the oil industry tried very diligently to extract more things out of the oil. Well, they've now done such a good job of it that if they put it through a coker, then liquid asphalt or petroleum asphalt is not a product anymore. So there are some refineries in the United States that don't produce asphalt. Obviously, that's a serious thing for those of us that are in the asphalt business. And then I had this on here, and I just wanted to show you just for a second that oftentimes you hear people refer to asphalt and tar interchangeably, and that's not the case. Tar that is oftentimes used on roofs and that type of thing, you hear coal tar pitch, that's a product that comes from coal production, not from asphalt production. So that's all that I wanted to touch on that. But so in other words, what is occurring in a barrel of oil is they're taking off all these products, and in some instances, petroleum asphalt is not going to be a byproduct. So we have the petroleum companies becoming more sophisticated. We have liquid asphalt not as plentiful as it was, and we also have a barrel of oil increasing substantially in price. So all of those things have gone together to drastically increase the price of petroleum asphalt in the last 2 or 3 years. The next thing that I want to talk about is the fact that in the United States we have not built a refinery since the mid-70s. So none of you were born, I don't believe, I'm sure, well, maybe the 3 people standing up here, but none of you were born at the time that a refinery was being built in the United States. So we have tremendous demand for petroleum products. We've got refining systems that are changing, and we don't have any additional capacity.
this capacity problem is serious. There's a lot of people in the world, a lot of experts, that don't think we have an oil shortage at all. What we have is a refining shortage. We are not doing a lot about it in the United States, and as I said, we haven't, because refineries tend not to be very clean, and a lot of people, quote, don't want them in their backyard. Saudi Arabia is building a couple new refineries. There's other places in the world that they're building new refineries, but the United States is not one of them. I think the refining shortage is going to be an extremely serious problem going forward, and I don't see it being corrected. If somebody started a refinery in the United States today, started building it, it would probably be 10 to 15 years before it ever came online, by the time they got the regulatory approvals. As far as a ton of liquid petroleum asphalt at our plant, I looked up some prices. Normal asphalt, not anything sophisticated. In July of '04, it was $175 a ton. In October of '05, it's $200 a ton. And in '06, they're predicting $250 a ton. So that's how the price of oil or of liquid asphalt has increased.
Now, if you bid something for DOT, for example, at a certain time, and these things happen, and oil prices went soaring.
If most of the petroleum companies today, if we are able to tell them what our need will be in '05 and what our need will be in '06, they'll guarantee the price. If, however, we miss those projections, then they won't guarantee anything over that. You're going to pay market price. There is an effort afoot for the first time that I can ever remember of trying to say that they will only pay market price. That hasn't gone very far. ConocoPhillips has kind of made that shot across the bow, but the rest of the refineries are not going down that path. So if we have a project like we do that are a 2-year project, they'll tell us what to use to bid in the first year and in the second year.
What if you say you need more? Do you still have to buy that? Or?
If it's in that first year, that's not normally an issue. They will sell it to you at the price they agreed to. In other words, if you are ahead of schedule, that has not been an issue. Where you really get in trouble, and we had a project. It's been several years ago, but in this part of the country, this is not a very good area to really build roads because the topsoil is so thick. We were building a highway, Interstate 72, west of Springfield, and the dirt contractor ran into a bunch of peat bogs over there that had to be totally excavated 8 to 10 foot deep and more dirt brought in. So instead of our laying the asphalt in the fall of one year, it was the fall of the following year. The petroleum company would not stand the price, and so it cost us a tremendous amount of money. But normally, if things are pretty much on schedule, they will sell it to you early, and then. But again, your estimators have to be able to coordinate with your field people to know pretty realistically what you're going to get done in what periods of time. And we use sophisticated schedules in order to project those types of things. Well, let me move on to cement for a little bit. That's probably a product that you're a lot more familiar with. As you know, cement is kind of a face powder consistency. It is really made from crushing down stone or crushing limestone down into that face powder material. That, of course, is then mixed with stone and sand and water to produce concrete that you'd see out on a parking lot or curb and gutter or sidewalk. In this area, most of the good aggregate for making cement, for some reason, is located along the Mississippi River.
you have deposits that I guess were formed by the glaciers, and so as you go across the state or go across the country, as an example, if you go to Tennessee, you're going to run into granite. Granite runs up to about the Ohio River. We don't have any granite here in Illinois at all, but we've got a lot of limestone. But over near the Mississippi, they've got some good stone that makes cement. If you were, well, you probably don't recall, back in 1993, there was tremendous flooding all up and down the Mississippi River. If you lived over in western Illinois, you might remember it. During that period of time, there were a lot, and I mean dozens, of smaller cement mills that were flooded out and destroyed. It was not economically feasible to restart those cement mills. So all of a sudden we had a huge number of companies that just went out of business. They couldn't meet the EPA regulations. They were so small that if they went back into business, they couldn't pay for the rebuilding, that type of thing. So in order to get the cement that we need in the Midwest, we're buying a lot of cement from Mexico and from South America. And it comes up the Mississippi River on barges and is unloaded. If you think about putting a load of cement on a barge in South America, and it starts toward the Midwest, and all of a sudden somebody in China says, hey, we'll pay you 1.5 times for that load of cement what they're paying you in America, it doesn't take long to make a left turn, go through the Panama Canal, and head for China. And that has been driving up the price of cement in the Midwest tremendously. As a matter of fact, in October of '04, a ton of cement delivered was $85. 10 of '05, it's $104, and they're projecting in '06 about $115.
$84 was '05.
Yeah, $85 was in '04. Yeah, in '05 it was about $104, and in '06 $115. Now that's delivered into this area of the Midwest.
Any idea what the Spanish cement would be compared to South American cement crossing the Atlantic, the others way?
I have no idea. When ready-mix companies here buy cement, they will deal with a dealer, and at the time you place the order, you don't know where that cement is coming from. The same with us. When we place an order for liquid asphalt, we don't know whether it's West Texas crude, whether it's Venezuelan crude. Very little of this product comes from the Middle East or Saudi Arabian countries, because they can refine it into gasoline, and there's a much better market. But we get by far the majority of our product either from in the United States or from Mexico or Venezuela or Canada. And I think that shipping is the main factor. We'll talk about just recently, there's been an announcement that there's going to be a huge cement factory built down near Cape Girardeau, which is a couple or 100 miles or so south of St. Louis. This will be the first new cement plant in the United States in years, or at least in the Midwest in years. But again, it's going to take 5 or 6 years for that thing to be built. So it's not an easy or simple process. Let's talk about structural steel, or reinforcing steel rather, which is another key component to both vertical and horizontal construction. Yeah, that's fine. Again, over the last 20 to 30 years, virtually every major steel manufacturing plant in the United States has gone out of business. You know, there's no more U.S. steels, there's no more Ryerson steels, there's all of those for various reasons have gone out of business. Now, there are a lot of mini mills in the United States, and those mini mills have been put online for a couple of reasons. Number one is that they will primarily produce a very, very specific product. They'll produce stainless steel for possibly the home building industry, for sinks or something like that. They'll produce steel for the automobile industry. They'll produce very, very high quality steels. But a lot of the mills that produce the structural shapes or the reinforcing steels have just gone out of business. So when we order those components, like the steel beams on that bridge that you saw, it's not at all unusual to have a delivery date 4 to 6 months from the date that you order those. So if you get a contract, one of the first things you do is you order the structural steel so that you can get it online, because there just aren't that many manufacturers anymore that are producing those types of steels. In addition to that, the demand in China and India and around the world is increasing at an extremely rapid rate. As a matter of fact, you know Rural King. Have you ever been out to the Rural King store here in Charleston? Well, they ship goods in from China in containers. When those containers get here, in order to ship something back to China, they're sending those containers to Decatur. They're loading the containers with scrap iron in Decatur, and they're shipping them back to China. In China, there's a tremendous amount of this type of steel production. One of the drawbacks, though, is that the Chinese steel production is of extremely poor quality, and so there's not much of it used back in the Western world or in the U.S. or Canada, and as a matter of fact, we cannot use it here in the United States in public works construction projects because of the poor quality. But I read an article recently that indicated that as fast as the Chinese population is growing, that they're going to have to produce 10,000 jobs a day, every day from now on, to have something for their people to do. In addition to that, 1.5 million people are moving from the farms to metropolitan areas a year in China. So that means that their demand for raw products, whether it be cement or whether it be oil or whether it be steel, is going to go on for a long, long time. That situation is not going to change quickly. So there are a lot of forces that are driving up construction prices in the United States, and from my perspective, I don't see those forces changing at all. When you come to our plant on Wednesday, you're going to see this laboratory, and we have a laboratory much like this at every single one of those asphalt plants. This one is bigger because it's at our corporate headquarters, and we do more mixed design work here, but we're required to have a lab like this at every plant. The reason for that is, like I indicated before, IDOT requires that we test all the raw materials that go into a product, and then we test these samples out of the roadway. And when we cut a sample out of the roadway, we can do different things with it. We can break it to test certain things. We can heat it back up again, and when we heat it back up again, we can separate out the liquid from the stone. So then we can test the stone and we can test the liquid. So we're required to do a lot of that testing on any product that we produce. We also test concrete. Mostly with concrete, you test it in beam breakers so that you destroy the sample because you're looking for tensile strength. But when we do a project for IDOT, they specify what they want. In other words, do they want a concrete road? Do they want an asphalt road? Do they want steel beams on a bridge like we saw? Do they want precast concrete beams on a bridge? They'll specify in the bid documents what they want. But as far as the mix, the composition of this, we do have leeway on the composition of this product. We will come up with a mix design in our laboratory, and then IDOT will have to approve that mix design. They won't let you just go out there and put anything down. They have to approve it, but we can come up with a mix design that may be less expensive for us to make than some other mix design. When they indicate to us what product they want us to use, that's not a flip of the coin. They've gone back and they've looked at raw material prices. They've looked at the price in place. They've also looked at life cycle costs. Life cycle costs in our industry refer to how much it's going to cost over time to maintain that pavement. I assume that in vertical construction you probably have the same thing. Somebody is deciding whether that building is going to have a steel skin, whether it's going to have wood shingles on the outside, whether it's going to be masonry, whether it's going to be brick. Probably not in home construction, but in commercial construction, somebody is looking at that and looking at a maintenance factor going forward 10 to 15 years, and that's exactly what IDOT does in an effort to determine the best product for the best location. The stone that we get that you saw being produced in this part of the country, it either comes in rail cars or it comes in trucks. So it's tested at the plant where it was produced. Then when it comes to our stockpiles, we have to retest it again. And again, that'll be in the laboratory. Go ahead. Go ahead again. We'll show you this on Wednesday. Now, when the material gets to the asphalt plant, we use end loaders, heavy equipment, to make the proper blends. And what did I do with my clicker? Did I lose it? Oh, there it is. Good thing. These will be different kinds of aggregate in each of these bins, and we will have determined the mix design that we want in order to get that finished product. Obviously, we use an end loader to feed these bins, and then the material goes through these feeders, and each of those feeders are calibrated, and again, to give you a proper mix design. They're then loaded on what's called a gathering conveyor, and they come up to the asphalt plant. Go ahead. Would come up here and end up dropping into the dryer. This is where it's heated. This, incidentally, is called a bag house, and its only purpose is to take dust out of the mixing process so that there's nothing that comes out of this stack except steam. So when you see an asphalt plant running, you won't see any dirt or anything else coming out, and the reason is a bag house. There's about 800 basically what look like vacuum cleaner bags in there that are about 8 inches in diameter and about 14 feet long. And the air just goes up and down, up and down, up and down, up and down, and comes out the back. As a matter of fact, that dust that we collect is collected down here, and there's another conveyor here, and we bring it up here, and we use it back in the asphalt mix. So we don't waste any of that dust that's collected. And as a matter of fact, that dust that's collected looks very much like the raw cement that you may use in here occasionally. And that's a very expensive product. So the more we can collect, the better, the better off we as an asphalt producer are. This again is just part of that dryer. The hot product comes out here, comes up this, what we call a slat conveyor. Go ahead.
Double barrel is just a name or a real thing, double barrel?
Oh, that's just their product name. That's just like, Chevy or Ford. Comes up this slat conveyor, and then the hot mix asphalt goes into these two silos. We are able to store asphalt for hot asphalt for a certain period of time, because these again have pipes around the outside. The state of Illinois would allow us to keep asphalt in these storage containers for about 24 hours. But most contractors don't like to store asphalt that long. We can store it here if you have a shortage of trucks for a while before you can stop the process, and the trucks will pull under here, and then we can load them quickly and get them out. But by and large, in Illinois, you don't store that asphalt more than a couple hours. Concrete, as you well know, once it's dropped in the mixer truck and the water added, you just have an hour. So we have a little bit of an advantage there, but these are the asphalt storage tanks. Once the asphalt is loaded in trucks, it comes back out onto the highway. This was down on I-70. It's dumped from here either directly in the paver or in this case into a material transfer device. Go ahead. There'll be another picture of a material transfer device. There it is. And this just has a capacity of remixing it, and it can store about 35 tons in here. So again, you don't have to have a truck in front of the paver each time. So it gives you a little bit of leeway when you're laying asphalt. This is the paver, and then the mix goes through the paver and is flattened out back here.
This truck or this container has the ability or capacity to heat, keep hot?
No, it's insulated, and there's great big augers in there, so it has the capacity of mixing it.
Just mix, but not heating hot.
Not heating, no. This again, it comes up here, drops into this thing, and then goes in the paver, and then is flattened out. Gets some density through the paver, but is flattened out in the back. This is a Blawnox paver that used to be made in Mattoon. They're now made in Pennsylvania. Just another picture. Go ahead. This was another operation we'll talk about in a little bit, but on Interstate 70 it had gone way beyond its design life. So we went in there and we crushed up the original concrete pavement. I'll show you that in a second. And so we didn't want to run trucks on that crushed up stone. So again, we used a material transfer device, and we had the paver over here. This was a national demonstration project put on by the Asphalt Pavement Association. So those crazy looking cowboy hats are actually hard hats. Why they did that, I have no idea.
Just roughly, what are the layers from the soil to the finished product? How many layers do we have?
On Interstate 70, we put about 17 inches of asphalt, 17 on this particular highway. The first lift was 6 inches thick, and then we went up in various lengths, various thicknesses of probably another 4 and a 4, and then probably 2 and on up to the top.
Do you call these base or sub-base or?
The mixes will be different, and so you refer to it as the mix used rather than base or sub-base. Yeah, so we would be putting down what's called a binder mix, and then it would have a number associated with it, a 105 or something like that. Go ahead. This again was when we were laying the 6-inch lift of asphalt. Go ahead. And here again, you can see how thick that lift of asphalt was.
The next layer would blend to this after it hardens?
Yes, absolutely. It will normally adhere to it very, very well. Down here on Interstate 70, because of the traffic volume, we did spray prime, and that's a prime truck right there. We sprayed prime on every single lift to give it more of an adhesive. On a normal roadway, you may or may not do that depending on what the state specs are.
Now, coming from Mattoon to us, you drove east on Lincoln, and you have this pump. Well, why is that?
Well, because that was originally a concrete pavement, and that's the cracks in the concrete pavement. And that was one thing that they wanted to eliminate on I-70, So we went in and we crushed up all the concrete pavement, and again, we'll see some pictures. Go ahead. And we made it back to stone so that there wouldn't be any bumps. This is the rollers that we had on Interstate 70. Go ahead. Again, more equipment, more rolling. Go ahead. This was, again, these were the bridges that we had down here that we had to raise because of adding 17 or 17 and a half inches. So we took the bridge decks off of that, and we totally we reused the steel, but we took all the concrete off. We cleaned up the steel. We put new studs back on the steel, raised the abutments in the piers, or we tore out the piers, used the abutments, and raised the bridge by 17 inches, and then we poured a new bridge deck.
When you have a thick layer like this, for example, cooling, do you have any problem with differential cooling? I mean, this cools first and this is still hot.
Not as long as you have good warm weather, like you might have in June, July, or August. When you get into October, November, early December, then you do have some problems that way.
Any cracks? Any?
That's always a possibility. Around here, we pretty much stop paving before Thanksgiving. Now, down in the southern areas, they'll pave longer than that, but part of the problem is cracking. Go back to the last one a second. You see this bridge here that goes over the interstate. There were 4 of those, and we had to go in, and they weren't going to replace the deck, so we had to jack up those bridges 17 inches, and the whole deck all at one time. So you have a series of jacks, and you jack up the bridges and hold them in place, and then you pour concrete spacers underneath the bridge and on top of the piers, and then you let the bridges back down again. Here's the machine, one of the 4 machines that were out there. Here's the concrete pavement before it was broken. All the existing asphalt had been taken off of it, and then you use this, and it's a multiple hammer, kind of like a pile driver, multiple hammer, and it crushes up the stone back to at the bottom of the 8 inches, maybe 6 inches in diameter, and then 4 inches, and then on the top, it's going to be kind of like stone that you just see out on a driveway or something. Go ahead. During the process, you'll have a lot of slivers, and then they bring another piece of equipment in, and it breaks it up into fairly square type pieces. During the demonstration, the people wanted to see the reinforcing steel. We just leave the reinforcing steel right in it. We don't normally pull it up like this. Let me go on just a second. We'll leave that slide up there. That was erecting the new asphalt plant that we bought for the Casey project. This project was the biggest project that we'd ever done in the history of our company, and probably the biggest project that we'll ever do. It was so big that we bid it joint venture with another contractor. They bought a brand new asphalt plant, and they put it on the east end of the job over by Marshall. We bought one, put it on the west end of the job in the area of Casey, and then we had a third asphalt plant at Greenup, and we ran some mix out of there also. The total quantity of asphalt that we had to get down in the 2-year contract was 550,000 tons of asphalt, 5,500 cubic yards of concrete, 160,000 cubic yards of borrowed dirt, which is dirt that has to be hauled in from another location, 90,000 tons of stone that went on shoulders and other parts of the project, and 200,000 pounds of rebar. As I indicated, we jacked and raised 4 bridge decks, and then we totally rebuilt the one bridge. This was a joint venture between two family-owned firms. The other bidder on the project was a huge company, Walsh Construction, out of the Chicagoland area. If you've ever driven down in the city, a lot of times you'll see buildings and the overhead cranes might say Walsh on it. That's the contractor. They have annual revenues in excess of $2 billion. They're family-owned too, but they could squash us like an ant as far as size is concerned. But they're huge. But anyway, that was a huge project. When we estimated it, and we'll go back to estimating in a second, we estimated that in order to get this done, we had to produce 6,000 tons of asphalt a day. Now think about that. A semi holds 21 tons. So we were going to have to produce 6,000 tons a day, and we were going to have to get that material into the plant. So in other words, you had to haul in 6,000 tons of stone or sand or the various components, steel slag. Then you had to mix it and haul it back out again. We had a few days when we were running all three plants full blast for 10 to 14 hours that we were producing over 12,000 tons a day. So you think about those quantities of having to get material in and get material out. Trucking became a huge issue. In addition to that, traffic control was a huge issue. You're talking 200 or 300 truckloads a day. How do you control them? How do you make sure that they get back to the asphalt plant on time? How do you make sure they get out to the paving spread on time? Obviously, when we were paving on the west end, the other company was paving on the east end, and then the third plant was paving in another location. So we had 3 separate paving operations going on at one time.
How will the project manager take care of problems when they arise? I mean, problems will arise, and things will not go as smooth as possible. When this big movement.
Well, obviously, it takes good people. That's the obvious. That's the first thing. We set up a whole office down at Casey. We had a project manager. We had support staff in that office. We had project superintendents on each one of these operations. In other words, we'd have a project superintendent on raising the bridges. We'd have another one on rebuilding the bridges. We'd have another project superintendent at each of the paving operations. So, if something happened, obviously it was that superintendent that was the first, I guess, line of defense. We had mechanics on the job full-time, and so they tried to coordinate it, and the project superintendent was the one that, if it got beyond, a project manager, if it got beyond the project superintendent level, then the project manager got involved. In addition to that, we were the controlling contractor on that project. In other words, the state wants one contractor to be held ultimately responsible. We were the contractor in the joint venture. So our support staff in Mattoon, as far as estimators, because you're always running into problems, something always is, they need a unit price for this or something like that. So it was a major project, and we worked a lot of long hours on the main line bridges that you saw. We worked 24 hours a day. Once it was so critical, because obviously if you're paving up to the bridge has got to be completed in order for you to get across it. So we worked 24 hours a day on that project, and we're building a lot more projects where we're working around the clock. We just finished a bridge. If any of you go to St. Louis, when you get west of Vandalia, those 2 mainline bridges on Interstate 70 that are completed now, but you kind of had to go like this. That was our project. We worked those 24 hours a day. Project at Effingham we're working on right at the Keller Ramada Inn. They're off ramps. They're redoing all those. We worked those 24 hours a day, certain phases of it. Certain phases we did not.
Lighting system is 24-hour 7 thing. Lighting system is a project in itself. You do it by your own crew or your sub?
No, to date, we've purchased a lot of what are called light plants. They're small contained units about as big as this table that have a diesel motor on them, plus a generator, plus they have then the lights that can be elevated and turned in directions. You can rent those things, but again, we normally, if we're going to use them for any length of time, we go ahead and purchase them. So we own a lot of those. As I indicated, this project was major for our company and major for this area. The project had penalties of $30,000 a day, and those penalties went on forever. There were incentives of $40,000 a day, but they would pay you for a maximum of 23 days. So, in our way of thinking, if you could be penalized forever, why can't you be paid bonuses forever? But they didn't agree with our thinking. And these are all set up in the contract, so when you bid them, you know exactly what's going on. In addition to that, we had to guarantee the project for 5 years, the bridges and the paving. So we did that. We finished it in '03. So we've got certain phases would come up in '07 and '08. So if there's any problems with the roadway, any problems with the bridges, it's our responsibility to go out there and repair them before the state will accept them sometime in 2008. Equipment is extremely important in our industry. This is, as I said, this is an asphalt plant that we bought brand new that was erected on the site. Go ahead. They are expensive. You have a lot of end loaders and cranes that are necessary that you use on a daily basis. Go ahead. This is the plant when it's basically in its final configuration. We have since taken this plant down and moved it to Effingham. So if you're familiar with Effingham, as you're going on where Interstate 70 and 57 are combined, the very first Effingham exit is at US Route 45. And if you look up in the northwest quadrant, you'll see this asphalt plant sitting there.
These silos will go one piece on the trailer?
Essentially, yes. Obviously this comes down, that's in one piece. This is one piece that comes off. This framework all comes off, and then each of these silos would be a trailer load. Yeah. I can get an idea here of some of the equipment. You've seen a lot of it already, but no, that's go back to the other one. You've seen a lot of it already, and we'll see more of it. But you can see rollers back here. You can see trucks and material transfer devices. Go ahead. This is what the project looked like during the course of construction when we had to build it. The westbound lane one year, the eastbound lane the other year. So obviously, in order to do that, you had to have two-way traffic on one lane for a while. So we had to put concrete barriers out, which we did ourselves. We do a great deal of the construction all ourselves. We sub out only really what is required to be subbed. We had to put these light reflectors so headlights would not shine in the other lane. We laid the asphalt. This is the rumble strip that is required, and that's actually cut in there by a small machine called a rotomill, and it goes down the pavement and it cuts. So if automobiles or trucks start to veer off, they hit that and makes a noise, and hopefully we'll wake you guys back up again or something like that.
Is that done while dry or?
No, it's done after it's all cold and hard. So that is an expensive operation. We do subcontract that out. That'd be a series of diamond blades, for 12 to 18 inches wide. So it's an expensive operation.
How
And that
do they control the alignment? I mean, they're perfectly aligned.
that's all done electronically.
Laser thing?
They would, in this particular instance, you can see here's the edge of the pavement. They would have some kind of a laser or electronic guiding device that would guide off this edge of pavement. And then here's part of that shoulder stone. I said there were 90,000 tons of various kinds of stone out on the job, and that was part of it. Just go back a second. This is a good example. This asphalt is considerably different than that asphalt. This asphalt is some of that steel slag asphalt, extremely high quality, made with polymer liquid asphalt, some of this that has polymers in it. This over here, which would not have traffic on it on a daily basis, is a much less expensive asphalt, has less asphalt content, and so you can see the difference in the color. So we don't put color in it at all. That's just because those are different kinds of asphalt. Go ahead.
Do you care for 5 minutes break or something?
Yeah, that's fine, yeah. Oh, no, it's whatever.
Do you need care for 5 minutes break?
Yeah, why don't we just take a 5-minute break? That's
Okay.
fine. I could get a
Break
drink
for
of
5
water.
minutes and come back.
To digress just a little bit, I'm talking an awful lot about asphalt, but last year our company probably had more volume in concrete work than we did in asphalt work. If you guys and gals think about a box culvert, and we build a lot of box culverts. We're doing some as we speak. But one of which we built last year was about 300 feet long. It was about 30 feet wide, and of course it was what we call a 3-barrel. In other words, there were 3 sections. So you pour a concrete floor, you pour the outside walls, you pour the interior walls, and you pour a roof on top, and then of course you pour the wing walls, which are out from either end of it. But that's just like concrete construction. If you were building a home that or a commercial building that had the first floor concrete, you'd do it exactly the same. And those people that build our bridges and our box culverts are carpenter foremen. We have 2 supervisors or superintendents that came up through the ranks, through the union ranks as carpenters, and they were carpenters and then carpenter foremen, and now they're carpenter superintendents, and they're the ones that build our bridges and our box culverts. So we buy a lot of lumber. As a matter of fact, at one point in time, we were buying form lumber in railroad car lots. And we build a significant amount of bridges every single year. And again, from one of the early pictures that you saw of the steel I was pointing out, but if you looked at all the lumber, all that's form lumber, because you've got to form the bottom in order to pour the concrete deck.
Do you reuse that phone number?
Absolutely. As a matter of fact, a big part of a project carpenter foreman or a project supervisor is to figure out what he can do with a 4x8 sheet of plywood so he can salvage that. If he goes out here and he could, lay it this way and be able to salvage the whole thing, but he decides to lay it this way and he has to cut it up into 4 pieces. We can't use those 4 pieces any longer. So he's really increased the cost of what he's doing. So the way he plans his forming is very important. What we call the stringers underneath, we use a lot of double 2x6s, double 4x4s, a lot of double 2x8s. And the way he, if you're buying 2x8s and you're doubling them, and then you're cutting those up into small pieces, we can't use those any longer. So it really makes a difference. Maybe it's cheaper to go out and actually buy 4x4s. You go down in this area, we still have lumber mills south of here down by Clay City, and we'll buy rough cut 4x4s. Those are a lot cheaper than putting in double 2x4s or actually even cheaper than double 2x6s. So your forming costs depend a lot on your raw material, and you better believe we try to salvage as much of that as we possibly can. Let's go on. This is some of the testing on the job site. When we lay asphalt, we lay it hot and we roll it immediately because we have to get a certain density. In other words, we test these in our lab, but we test them out there, and if it is not a certain density, then it's not going to have the longevity that we want. Just like your concrete, if for some reason it doesn't reach the strength that you want, then you got big problems. Particularly if you're building a skyscraper, you're up on the 30th floor, and all of a sudden your strength of that concrete drops down probably below 4,000 psi. You're in big trouble. And the same thing with asphalt. We've got to know that we're achieving density, or the state can make us come in and take it up and replace it. This is a nuclear density meter. You see our man here has got a dosimeter that he wears. Well, that's probably his cell phone, but he will be wearing a dosimeter. He's had training, and the reason that we lay out a pattern across the mat this way is we want to make sure that density is consistent all the way across there. We also want to make sure that density is consistent right at the center line. If you drive down a roadway and you see problems with a pavement, whether it's asphalt or concrete, probably initially it's going to be right on the center line. Watch that if you have an opportunity, and if you start seeing the spalling here in the concrete or pieces of asphalt breaking out, what that means is it means is that this probably was not consolidated well enough during the time of construction. Water begins to get down in here, and then it starts breaking from the bottom up. And so it's very, very important that you know what the densities are across that mat. Go ahead. Yeah, really it's mineral filler, just like cement dust. When this machine, and it's a nuclear device, so actually what it's doing is kind of like I guess kind of like sonar in the Navy. It shoots rays down into the surface, and then it measures them when they bounce back up again into the machine. We found over the years that a lot of times the porousness of the very, very top surface, in other words, this porousness right there will affect the reading. So what you want to do is just fill those, because this porousness here has nothing to do with the consolidation down here. So we'll fill that with some of that white powder, mineral filler, in order to do that. This is a way of testing the smoothness. When we lay an asphalt pavement, or a concrete pavement for that matter, there are various types of testing devices. This is one form. Some of them are pulled behind a pickup truck. The very, very sophisticated ones that some of the state agencies now have are actually mounted in vans, and they have lasers at all four corners, and they can run down a roadway at 50 miles an hour and test the smoothness.
This is a driver there?
No, this actually is just walked. This is not a self-propelled unit. This is a computer up here, and this is a printer and this is a laptop. If you see it, there's another picture, I think. Go ahead. There we go. And this measures, and then it comes off here just like a if you've been to a doctor, an electrocardiogram, you know, it comes off with a thing here that will measure the roughness of the pavement. Now, let just show you, this was kind of interesting. While we were down there building Interstate 70, one of the laborers came up and he had some photographs of when Route 40 was built originally in the 1920s. Route 40 was the major highway that I guess was built all the way from the East Coast to the West Coast. And it was the first probably public roadway that went coast to coast. And look at these guys. You know, some of them have coats and ties on, and these were the kinds of piece of equipment that they used back in the 1920s. Go ahead to the next one. These are the trucks. Look at those things. You know, we have semis out there that haul 21 tons, and in Michigan they haul a lot more than that. And look at this. You had a driver, and you know, and the driver sat here, and this was a wood bed, and they didn't have any hydraulics on that thing. You loaded the load on the back end of the truck, so when you flipped the lever, it automatically dumped it. And then after it was dumped, then you grabbed a hold of a rope and you pulled it back down again and lashed it, and you went back and got another load. So so that's the way they built things. Now, and I think that the way they loaded the trucks was they loaded the stone up here, and the truck drove under it, and then they dropped the stone into the truck. So.
These containers that you see on top, this is a container, like modern containers.
Where is this?
Yes, this one.
Here?
Up,
Oh, there? I think, I'm not sure, but I guess in order not to have to wait on every single truck, I imagine they used a small crane, and that they took the stone from here and put it here. So then when the driver drove underneath here, it probably was a measured amount, and they could pull a rope or something, and it would drop probably 2 tons or 3 tons or 4 tons or whatever they had. I've also got some pictures. I didn't bring them, but for concrete construction, you'll get a real kick out of this. Instead of having a ready-mix plant that mixed the concrete and loaded it in a truck and came out on the job, they actually had a concrete plant that was on railroad tracks. So you went out and you laid the tracks down, and then the concrete plant moved along as you were mixing the concrete and pouring it. Well, when the trucks came in this way, they weren't in the right position to dump. So, so they had a thing on the railroad track that the little truck came up, and it drove up onto the railroad track sideways, and it was a little turntable. And the driver got out, or they may have had an extra labor. They physically turned the truck around, and then he backed it down the railroad tracks and dumped the stone into the skiff, and then it was lifted up into the concrete plant. And then the truck, you know, got off and drove away, but then when the next one came down, they had to turn that little guy around and back him into the plant. So this is kind of some of the new equipment that we use. Obviously, end loaders and hydraulic excavators. We're putting what's called riprap down in the ditch, and so we're carrying it down there with this piece of equipment, and then we're replacing it with a hydraulic excavator. Go ahead. We do use lasers. We use grade control. Years ago, you know, you had people on the back cranking. We don't use that anymore. This is what's called a ski. The electronic grade control is working off the ski. The amount of asphalt that is here is controlled by a laser that reads the asphalt in here. We have electronic GPS systems on our motor patrols and our bulldozers that work off satellites. And go ahead. And those are kind of funny because if they're working off satellites and you're working on a building site, you can be fine here, but when you get up next to the wall, if the satellite happens to be over here, the motor patrol can't pick up the signal. So so they're putting up more satellites to eliminate, or if you're working and you're going through a forest area and there's a canopy of trees, it won't pick it up. We'll go back on the other one. Our asphalt plants now, instead of having a lot of labor around doing various things, they're all controlled electronically. These are obviously 2 computer monitors, and you can just see vague outlines. It shows you what's going on in the asphalt plant at any given moment. And as a matter of fact, it talks to you in a human voice if something starts to go wrong. In other words, let's say that you've got a 200 horsepower engine on your dryer, and the amps are increasing on that engine. It'll actually come up and say, alert, amperage is thus and so on engine number 4 or something like that, and then you can either send somebody out, or you can start to shut it down so you can check to see what's going on. So it's kind of fascinating. I want to spend a little bit of time talking about another project, and evidently the camera person down here or back here is an Indy 500 fan. We did not do this project, but a company I'm very, very familiar with did, Milestone Construction in Indianapolis, and the engineer on the project is a good personal friend of mine. But this is the Indianapolis 500, and and like every other piece of pavement, whether it's on a highway or a parking lot or a racetrack, after years it begins to wear out. It begins to be affected by age and traffic. And a racetrack like the Indy 500 or a NASCAR track, they're just not used for the races. They do a lot of testing. They test transmissions, they test engines, they test suspensions, they test brakes. So these tracks are used a lot more than just on race day. And obviously on any project, whether it's a project for the Department of Transportation or a racetrack, you have to determine what is wrong with the track and what needs to be repaired. And normally that's done by an engineering firm. It's not done by the contractor. Even IDOT may hire an engineering firm to go out and test the pavement, and they will do that by taking cores just like this. Go on to the next one. And that's exactly what they did. You can see it's not smooth, and it's not exactly square. This is one that's been taken out of the pavement, and as you can see here, they have a different kind of asphalt here, different gradations, much bigger stone up here, and then smaller stone up here. The smaller stone will make a smoother surface. If this was the top surface, you could see it'd be very, very rough. But what is important in a mix like this is you have aggregate to aggregate contact, and that's true whether it's asphalt or concrete. You've got, in this particular instance, you've got asphalt cement between the individual pieces of aggregate, just like you would have cement in there. But look at all the aggregate to aggregate contact. So that's not going to rut very, very easily. Go ahead. Once the decision is made as to what is necessary, what repairs are necessary, they go in, and in this area they decided that had to be totally dug out, and that may have been dug out to take a sample so they could take it back to a laboratory, because you see the nice square edges. That's obviously been cut by a saw. They make it go back to the first. They make a determination, and then they once the determination is made, then they bring in in this particular instance, a rotomill machine, and what they're doing is they're grinding off the existing pavement. Now, a question was asked earlier about the work we did on I-70 and the work we do on other projects. During the evaluation process, money becomes a very, very important consideration. If we're doing, I suppose some of you would go to Champaign, maybe on Route 130. You know where Route 130 goes north out of Charleston? Okay, the volume of traffic on Route 130 would not justify the expenditure they did on Interstate 70, where they put 17 inches of asphalt. They would go out and they would test the pavement. They would test they would take traffic counts when you've seen rubber, look like rubber hose across the pavement occasionally. Those are traffic counters. They're trying to determine how many semis, how many automobiles travel that route per day. On a route like that, they would probably determine that it was cost effective to go in and take off 1.5 inches or 2 inches of the existing asphalt surface and then put it back down again. So the process that we're seeing here on the Indianapolis 500 is much the same that we would do on projects like Route 130, Route 45, Route 121, Route 16 between here and Interstate 70. I mean Interstate 57, and incidentally, Route 16. Our company was involved in building that when it was originally built. The old road was old Route 316 that kind of wanders up through the country, but we built all those bridges out there at one time, and we did a lot of the paving when it was originally concrete. One reason that they have to take this asphalt off is that according to racing rules, and whether it's NASCAR or kart or whatever, this has to be a minimum of 42 inches. So if it is 42 inches now, they obviously have to take something off before they can put something back down again. Going back to the highway situation, those of you that are from northern Illinois, the Chicago area, you know what the traffic is like up there. So those interstates, they have been rebuilding. You know, you look at the Dan Ryan, Congress, the Eisenhower, the Kennedy, all of those have pretty much been rebuilt because the traffic is absolutely phenomenal up there. And you get to a point after, say, 20 years or so, or 30 years, that they look at it and they say, we can't just go in and take off 2 or 3 inches. We've got to take it all out, and we've got to put up there probably 20, 24, or 30 inches of pavement back, because the traffic is so heavy that we don't want to have to go back there for another 30 years or 20 years or whatever the design life is. This process where you just mill off 1.5 inches and put 1.5 inches back on, you're probably going to have to go back probably every 10 to 15 years and do it again. But the traffic is not such that that's a problem. So there's a cost and effect evaluation that comes out, and so this is the method they're using. Go ahead.
When you remove the top part, would you disturb the lower? I mean, any disturbance happens to the lower?
No, not really. This is a very high speed, what they call a mandrel down here, that has carbide tipped teeth, and it actually has the ability to go in and actually grind off an asphalt surface and grind off concrete, and it really does not disturb the underlying. Yeah. Here's a picture where you see that it's all been ground off. See, it looks like there's paths going this way or marks. It's all been ground off at this point. They've started to lay the asphalt, and you lay the asphalt from the high side going down, because you always want the water to overlap going down toward the infield.
Is the only reason, or for the speed, for the central field?
Well, for both. For both, but whenever we lay asphalt, you always, or you normally always start from the high side and go down. This again is just another picture. They've got here's a truck. They've got a material transfer device just like we own, and then they dump it in the paver, and then they roll it right behind. Here again, talking about samples, what they're doing here is they're putting down steel plates, and then when they come over it with a paver, and then when they roll it, they'll be able to go back with a metal detector, and they'll be able to find where those steel plates are, and then they'll cut out sections of that track so they can take them back to a lab and test them and make sure that they are getting what they're paying for. Here's a different method. This again, they're coring the pavement, and this is part of the new track. So they're coring it, and again, you see that they're coring it right on this joint Here's one painted on the joint. They're coring it right on that joint because joints, again, are extremely important. And if you don't have compaction there, that's when you're going to start having wear. And again, with the speed and everything else that you have in a 200+ mile per hour race car, you don't want to have any problems with the joints.
The pouring would go like this,
Mm-hmm.
and then how you cut here?
You actually have a kind of a handmade device that you just put it in and you kind of go back and forth, and yeah, it's pretty primitive, but it works. That was the asphalt plant that they used to produce the mix that went out on the speedway. Go ahead. Here again is you can see the electronic devices that are used to lay the asphalt. And this is kind of an interesting picture because you talked about how many lifts we put down. Normally, we consider that when you put down a lift of asphalt that you're taking about 70% of the roughness out. So you got 70%, and then you got 70% of what's left, and 70% of what's left, and 70% of what's left. In this particular instance, since it's a racetrack, they've put down one level, and it appears this is a second level, and that's a third level. So they're trying to get it absolutely as smooth as they possibly can.
When you are pouring concrete, you worry about rain. If it rains, you cannot really pour concrete.
Mm-hmm.
Of course, water is an ingredient.
Correct.
How compared to putting
If you just have a light rain, it really won't affect it. But if you have a heavy rain, it'll start to cool down that asphalt, and it will actually drain through some of the pores. So we're very concerned about rain also.
You don't want rain water to come inside the mix.
That is correct. Yeah. Again, they must have had some kind of a time element here because they're paving at night. And they use special rollers. These rollers were from Germany, and the paver was from Germany. I don't know.